Hello, welcome to The X. Have you ever stopped in your tracks and looked up, wondering why the sky appears blue? It's a question that has sparked curiosity in minds for centuries. Some believe it's a reflection of the oceans, while others think it's just the way our eyes perceive the world. But are these beliefs accurate? Or is there a deeper, more scientific explanation behind this celestial hue? Well, the answer lies in the science of light, more specifically in a phenomenon called Rayleigh scattering. First, we need to understand what light is. Light, in essence, is made up of electromagnetic waves. These waves are spread out in a spectrum, often referred to as the color spectrum or the visible light spectrum. This spectrum encompasses all the colors that our eyes can perceive, from red to violet. Each color corresponds to a different wavelength. Now, here's the interesting part. The shorter the wavelength, the more blue the light appears, and conversely, the longer the wavelength, the more red it appears. So, if you picture the spectrum, you'd see red and orange at one end, representing longer wavelengths, and blue and violet at the other, representing shorter wavelengths. It's a fascinating interplay of physics and perception where wavelengths and colors dance together in the grand ballet of light. Now that we understand light and its spectrum, let's dive into why our sky appears blue. Enter Rayleigh scattering, the phenomenon responsible for our blue sky. But what is Rayleigh scattering exactly? Well, it's the scattering of light or other electromagnetic radiation by particles much smaller than the wavelength of the light. Imagine it as a cosmic dance, where light meets tiny particles and gets sent off in various directions. Fascinating, isn't it? Now here's the crux of the matter. This process isn't impartial to all colors. Short wavelength light, such as blue and violet light, gets scattered more than other colors. Why? Because it travels in smaller, tighter waves. It's like the difference between a marathon runner and a sprinter. The smaller, quicker strides of the sprinter, or in our case, the blue and violet light, gets around more quickly and widely. So, in essence, our sky is a canvas painted with the scattered light of the sun. But here's a thought to chew on. If blue and violet light are scattered more, does that mean our sky should look violet instead of blue? If violet light is scattered more than blue light, why isn't our sky violet? Good question. You see, our human eyes are more sensitive to blue light and less sensitive to violet light. This is due to the way our eyes are designed, with cells called cones that perceive different colors. The cones that perceive blue are more numerous and more active than those that perceive violet. But there's more to it. Sunlight reaches us with a lot more blue light than violet light. This is because of the sun's temperature and the way different wavelengths of light are absorbed and re-emitted. The sun emits light in a spectrum of colors, but because of its temperature, it emits more light in the blue part of the spectrum than the violet part. Additionally, the Earth's atmosphere absorbs some of the violet light before it reaches our eyes. So, the combination of these factors makes our sky appear blue to us. So, there you have it. We've journeyed through the fascinating world of light, explored its dynamic nature, and discovered the concept of Rayleigh scattering. We've unraveled the mystery of why our sky appears blue and not violet. It's all about the shorter wavelengths, their scattering in the Earth's atmosphere, and our eyes' sensitivity to blue light. Next time you look up at the sky, you'll know exactly why it's blue. Stay curious and keep asking questions. Thanks for watching. Subscribe and follow to get the latest videos.